General solution of trigonometric equations. Sine. Until now, we have learnt to solve algebraic equations. In this section, we shall learn to solve trigonometric equations. Consider sine theta equals 1 over root 2. Find theta. We can use the sine inverse function to solve this. On a calculator, this is shown as sine inverse, as a second function. We write theta equals sine inverse 1 over root 2. Using a calculator, we get theta equals 45 degrees. Let us plot a graph of y equals sine theta. We can draw the graph of a line y equals 1 over root 2 on the same graph. The intersection points are shown. We can see that the value of sine theta equals 1 over root 2 at each of the intersection points. Therefore, the possible solutions of sine theta equals 1 over root 2 are negative 675 degrees, negative 585 degrees, negative 315 degrees, negative 225 degrees, 45 degrees, 135 degrees, 405 degrees, and 495 degrees, in the interval negative 720 degrees and 720 degrees. The calculator only gave us one value, but there are many solutions. In fact, there are infinite solutions for this equation. This is because sine function is periodic. To arrive at all possible solutions, we use the following. If sine theta equals a and a lies between negative 1 and 1, theta equals sine inverse a plus k times 360 degrees, k element of z, or theta equals 180 degrees minus sine inverse of a plus k times 360 degrees, k element of z. These are called the general solutions of sine equation. This might seem complex, but let us go step by step. The k in the solution is an integer, shown as k element of z, the set of integers. K is multiplied by 360 degrees, since sine function is periodic in intervals of 360 degrees. In our example, a is 1 over root 2. Now, sine inverse 1 over root 2 equals 45 degrees. This becomes our reference angle. All other solutions are obtained using the reference angle. We substitute this reference angle in the above general solutions. We get theta equals 45 degrees plus k times 360 degrees, k element of z, or theta equals 180 degrees minus 45 degrees plus k times 360 degrees, k element of z, equals 135 degrees plus k times 360 degrees, k element of z. We have thus arrived at the general solution of sine theta equals 1 over root 2. Let us now find solutions in the interval negative 720 degrees, 720 degrees. We substitute different integer values of k into the above general solutions. Theta equals 45 degrees plus k times 360 degrees, k element of z, when k equals 0. Theta equals 45 degrees plus 0 equals 45 degrees, when k equals 1. Theta equals 45 degrees plus 360 degrees equals 405 degrees, when k equals 2. Theta equals 45 degrees plus 2 times 360 degrees equals 765 degrees, when k equals negative 1. Theta equals 45 plus negative 1 times 360 degrees equals 315 degrees, when k equals negative 2. Theta equals 45 degrees plus negative 2 times 360 degrees equals negative 675 degrees. We now substitute the values in the second solution. Theta equals 135 degrees plus k times 360 degrees, k element of z. When k equals 0, theta equals 135 degrees plus 0 equals 135 degrees. When k equals 1, theta equals 135 degrees plus 360 degrees equals 495 degrees. When k equals 2, theta equals 135 degrees plus 2 times 360 degrees equals 855 degrees. When k equals negative 1, theta equals 135 degrees minus 360 degrees equals negative 225 degrees. When k equals negative 2, theta equals 135 degrees plus negative 2 times 360 equals negative 585 degrees. We can go on finding specific solutions as above. However, we see that the values in blue are the only ones in the interval negative 720 degrees, 720 degrees. These are 675 degrees, negative 585 degrees, negative 315 degrees, negative 225 degrees, 45 degrees, 135 degrees, 405 degrees, and 495 degrees. You will recall that these are the same values that we obtained graphically. To summarize, we have derived the general solution of sine theta equals 1 over root 2 and specific solution in the interval negative 720 degrees, 720 degrees.
Need more help? Subscribe to our channel. Can't wait that long? Ask Mesky to help you and let the math finally start mathing.